This section will instruct the builder to finally install all the body panels, engine belly pan, and then install the skid pans. Locate the following components. Reference construction print E32-2000. Locate the hole in the bottom of the tub to access the fuel drain. Attach the drain cock mounting bracket to tub with 4 screws and nut plates. Make sure the steel braided fuel lines connected to the drain tee are positioned so that they will not touch anything. This is the engine belly pan as received from Rotorway International. With all the body panels installed, fit the engine belly pan to the bottom of the tub using 7 clecos. This view shows the belly pan installed with the Zeus fasteners. Cut the holes for the fuel filler caps only after the tanks are finally installed and bolted in place on the airframe. The hole should be about 3/4 inch larger in diameter than the fuel cap. The top of the cap should extend approximately 1/4 inch above the surface. Flush with the surface is also acceptable. Remove the caps from the fuel tanks and cover the holes with tape to prevent any debris from falling in. Shown here with hole already cut for clarity. Tape off the surrounding area if you have painted the body panels to prevent surface damage. In the center of the fuel tank hole, drill a small hole through the panel. After verifying position, open this hole until the fuel cap can be installed in the tank. Use a 3.5 inch hole saw. These are the skid pans and mounting hardware as received from Rotorway. There are notations for the inboard and outboard pants. It is recommended to fit the front skid pans first, as the rear skid pans are slightly more complicated. Allow 1/4 inch of clearance between the top of the pants and the body to enable the landing gear to flex. Sand and trim as necessary. Fit each set together. Cleco 2 places on the rear of the pants and the front where they fit best. This will help when fitting them to the landing gear. Check for approximate fit on the front skid with both the inside and outside pants. Remove the outside pant and hold the inside pant in position. Mark where the slots for the hose clamps are to be cut. Remember to allow 5/8 inch clearance on the leading edge for the nut plates that will be attached to the outside pant. Cut 2 slots 1/2 inch to 3/4 inches apart, centered on the leg of the landing gear. Install the hose clamps and check for fit. Use care when tightening the clamps to prevent cracking or breaking the fiberglass pant. Check the fit of the inside pant to the body with a hose clamp holding it. Remember the 1/4 inch clearance is required between pants and body to allow the landing gear to flex. After the top is positioned correctly, cut off the bottom of the pants to fit the shoe as shown. Reinstall the outside pant. Drill and clake with a front overlap for nut plates and screws. Mark and cut the top edge of the flare for clearance if necessary. Notch the pants around the step. Hold the outside pant in position on the rear landing gear. Mark the body where the top of the pant touches. Place the end of the tape measure on the mark and hold the 2-inch mark on the tape where it contacts the gear. Find the distance to the center of the ground handling bushing. Measure from the front of the gusset to the center of the bushing and add 5/8 inches to the measurement for nut plate clearance. Transfer this measurement to the outside pant as shown. Drill a 7/8 inch hole and fit the pant on the landing gear. After the top is positioned correctly, cut off the bottom of the pants to fit the shoe as shown. Repeat the previous steps for the inside pant. Then drill and install clecos to check the fit of both assembled halves. After the desired fit is achieved, mark the edges on the body. Remove the outside pant and hold the inside pant in position. Mark where the slots for the hose clamps are to be cut. Cut 2 slots 1/2 inch to 3/4 inches apart, centered on the leg of the landing gear. Install the hose clamps and check for fit. Do not over-tighten the clamps. Check the fit of the inside pant to the body with the hose clamp holding it. Remember the 1/4 inch clearance between the body and the top of the pants. Reinstall the outside pant. Mark and cut the top edge of the flare for clearance if necessary. Notch the pants around the step. After the pants have been final fitted and painted, glue the rubber molding around the top of the pants using the weather strip adhesive supplied. The seat cushion attachment strips are to prevent the bottom of the cushions from sliding forward, which could limit the movement of the cyclic control. When installed, the cushions must not extend in front of the seam where the fiberglass seat bottom meets the cyclic inspection covers. Place the strip on the seat cushion as shown. Mark the strip and cut it to length. Measure the length of the flap on the bottom of the seat. Transfer the measurement to the seat bottom, beginning at the front edge of the fiberglass. Drill a 3/16 inch hole, 2 inches from each end of the strip. Hold the strip in place and transfer the hole locations to the fiberglass. Drill holes and install an 8/32 nut plate in each hole on the underside of the fiberglass. Insert the strip into the flap on the seat cushion. Using an awl or other sharp tool, find the holes in the strip. Note, do not use a drill to make the holes in the cloth. The drill might catch a thread and unravel the cloth. Enlarge the holes enough to fit the screws through. Place the cushion in the cabin and install the screws. To secure the remainder of the cushion, glue strips of Velcro hooks to the fiberglass seat back or aluminum access panels with contact cement. Exact location is not critical because the entire back of the cushion is covered with material that will stick to the Velcro hooks. Note, remember when using contact cement, apply it to both surfaces being joined and allow it to dry for about 15 minutes before sticking the two surfaces together. This section will show the builder how to finish construction of the blades, cut out the pitch horns, install the blade straps, install the blades on the hub, make the lead lag adjustments, and static balance. It is recommended at this time, before installing the main rotor blades, the builder should attend Rotorway International's flight training school to review the rigging of the rotor system and controls. Locate the following components: reference construction prints E20-2000 asymmetrical main rotor blades and E49-2000 elastomeric rotor hub. Set up a table and level the surface in all directions. The blade straps are made at the factory as a set. Remove the straps and mark them to ensure that each set will be reassembled in the right order and to the correct blade. Measure the wood filler blocks on the root end of the blades. Note the cord line inscribed on the end of the blade. The filler blocks must be sanded to match the dimensions on construction print E20-2000. Using a number 2 pencil with normal pressure, cover the surface to be sanded. Use sandpaper wrapped around a block of wood for even sanding. Sand until all signs of the marks are gone. This method normally removes 0.02 of an inch. After sanding, verify the following measurements: 1. Overall thickness, 2.250 thousandths. 2. The cord line is centered. 3. The top and bottom wood surfaces and cord line are parallel. Use a 36-inch to 48-inch level to verify the wood block surfaces are parallel to the blades as shown. Reference the construction print to mark the blades to remove the trailing edge on the root end. Use a hacksaw or a portable bandsaw to carefully cut root end of the blade. Use a file and sandpaper to remove any burrs. Use a piece of paper to make an impression outline of the opening of the root end and cut out the paper pattern and transfer the outline on the wood end plug. Place the wood end plug next to the rotor blade and draw a line even and parallel with the rotor blade where the top and bottom skins meet. Draw a line even and parallel with the spar. Cut out and fit the plug to the root end of the blade, taking care not to change the shape of the airfoil. Drill the vent holes in the wood plug as per the construction print. Locate and drill the airfoil and wood plug for screws. Use at least 6 screws. Sand the mating surfaces and apply 3M structural adhesive. Install the wood plug and finish the root end of the blade. Do the same procedure to the other blade. Hold the wood for the tip end plug against the blade and trace the airfoil on the wood. Hold a piece of paper against the end of the blade and use your finger to trace an impression outline of the spar and skins. Cut out the paper pattern and transfer the outline on the wood end plug. Cut out and fit the plug to the rotor blade, again taking care not to change the shape of the airfoil. Drill the 1/4 inch vent holes as per the construction print E20-2000. In between the vent holes, drill 2 1/8 inch holes for number 8 by 3/4 inch long sheet metal screws if needed for dynamic balancing. Drill holes for the wood screws that hold the wood plug in the tip end of the blade. Use a number 47 drill for the pilot hole and a number 32 drill for the shoulder of the screw. Use a 1/4 inch bolt in the vent hole to help remove the end plug easily. Note, do not glue the end plug in place until after the rotor system is balanced. cut the tip weight material in half and drill the two 1/4 inch holes as shown in the construction print E20-2000. Locate and drill one attachment hole in the bottom side of the spar. Note the hole should be drilled at an angle to allow the head of the bolts to match the shape of the airfoil. Install a bolt in the hole, then use the tip weight as a template to drill the other hole. Note the rivet tails extending inside the blade where the tip weight is located can be removed to allow the weight to sit flush. Cut out and deburr the pitch horns. Fit the pitch horn clevis to the pitch horn. It may be necessary to radius the corner of the pitch horn so there is no gap between them when bolted together. This shows the aligner blocks as received from Rotorway. The blocks are marked with a T to indicate the top. The top must be up when the aligner blocks are installed into the blade so that the adjustment bolts will align with the studs in the rotor blade. These are the thrust blocks as received from Rotorway. There is a master marked with an M which goes on the end of the hub marked with an M. The slave is marked with a S. Both blocks have a top side as shown. These are the elastomeric thrust bearings as received from Rotorway. Deburr and round the edges of the blade straps. With a wire brush, roughen the surfaces of the straps to be glued so that the glue will adhere. Put the thrust block and the liner block between the retention straps. If you do not have enough 9/16 inch washers to tighten the 9/16 inch nut, you can use the pitch horn as shown here on one set of the straps. Place the retention strap assembly on a flat surface. Tighten the 9/16 inch bolt and the two 5/16 inch bolts to maintain alignment when mounting the assembly on the rotor blades. Turn the back of the thrust block towards the edge of the strap that has the 3 holes. This will make it possible to measure to the edge of the 9/16 inch bolt when mounting the assembly to their blades. Before applying the adhesive to the blade straps, check the assembly for fit. Use grease in the corner of the liner block and strap to prevent them from being glued together. Apply a thin layer of glue to the filler block and mating strap surface. Then slide the assembly so that the last bolt hole in the strap is at the end of the blade. Using a clean rag, wipe the excess glue from the end of the blade and strap. To mount the retention straps on the rotor blades in the correct location, do the following. Slide the assembly on far enough to install the 5/16 inch bolt that is at the end of the strap. Place a straight edge against the leading edge of the blade. Adjust the aligner block bolt to achieve the correct distance between the leading edge of the rotor blade and the center of the 9/16 inch retention bolt. This distance must be 1.985 inches to 1.990 inches. Note the chord line of the rotor blade, the straight edge, and the caliper must all be level when making this check. The distance must be the same on both blades. If this cannot be achieved, contact Rotorway customer service. When you have the correct measurement, hold this position and pass a 5/16 inch reamer or 5/16 inch drill through the remaining holes to ensure an easy bolt fit. Install the 5/16" bolts and torque them to 14 foot-pounds. Do not torque the 5/16" aligner block bolts at this time. Remove the thrust block and make the following checks. The distance between the two straps must be 2 1/4 inches to 2 3/8 inches. The straps must be straight. The 9/16" bolt goes in easy. Normally only the paint in the holes must be removed to achieve this. Referring to the rotor hub section in the maintenance manual is a good reference to help the new builder pilot understand the rigging of the rotor system. Before mounting the blades to the hub, level the main shaft 90 degrees to the ground both fore and aft and laterally. Shim under the skids as necessary. Verify the hub is shimmed correctly to the shaft. Since your main assembly is new, carefully rock the hub back and forth 15 to 20 times to lubricate the shims, since they probably haven't been moved in some time. Place a spring scale on the outboard pin and pull up or down until the hub plate starts to move. Read the spring scale and note the reading. The hub pressure must be between 8 to 12 pounds. Note, to keep the hub plate moving, it may require more pressure to start the movement. If your reading does not fall within these limits, refer to the maintenance manual on rotor hub shimming. As per the construction print E49-2000, you notice that the hub is centered on the shaft by using stainless steel shims and Delrin shims. Before mounting the main rotor blades, you must verify the hub is centered on the shaft. Refer to the maintenance manual to fabricate this hub fixture to measure the hub to shaft center position. Turn the hub so that the numbers stamped on the hub plate are on the pilot side and the hub is aligned fore and aft to the helicopter. It makes no difference which side of the helicopter the numbers are on, but it is a good practice to establish a normal and routine procedure. Place the fixture on the hub. Push the fixture up against the outboard pitch pins and hold the fixture down on the 3 rivet point contacts located on the bottom. Securely hold the fixture on the hub and rock the hub back and forth until the needle on the dial indicator stops moving in a central position. Then zero the indicator. Carefully remove the fixture and place it on the other side of the hub using the same procedures. Repeat the steps and determine if the hub is off-center. Hub centering must be within 1/1000th total indicator reading. If your total indicator reading is not within tolerance, reference the maintenance manual for the correct procedures to center the hub to the shaft. Set both blades on the table. Now you will be instructed to verify the reflexed edge of each rotor blade. Rotorway International has a fixture and instructions for measuring and making adjustments on the trailing edges of the blades to improve blade tracking if your rotor system's tracking changes through increased forward airspeed. However, at this point, the builder only needs to verify that each panel of the blade is adjusted to within 2/1000ths of each other for its entire length. The parts list for the reflexed edge fixture is as follows. When checking one blade against another, you'll notice the difference in the readings. The airfoils are matched at the factory. Trying to have both blades identical may induce vibrations. Each blade must be adjusted within 0.02 for its entire length. If your readings vary, you'll need to average the readings and adjust accordingly. With the use of vice grip locking sheet metal clamp pliers as shown, the edge can be bent up or down as needed. To avoid damaging the skin surface, glue some rubber strips to the pliers. Before proceeding further, the blades must be painted at this time, otherwise balancing adjustments will not be accurate. Rotorway recommends using a primer that will give you the best results in your environment. Then use a 2-part polyurethane paint. Refer to local aircraft painters or suppliers to find the best materials and preparations that are required. To help with the static balance later, remove 2 of the 3/8-inch bolts on one of the teeter blocks and replace them with smaller 1/4-inch bolts, washers, and nuts. Refer to the maintenance manual on rotor hub shimming. Place a C-clamp across the teeter blocks so that the clamp jaws clamp at the base and to the center of the block as shown. Place a 9/16" box end wrench on the 3/8-inch teeter block bolt head and turn the wrench to feel if the bolt moves easily after tightening the C-clamp. Adjust the clamp as necessary. Place a small amount of grease on the bolt threads and drive the bolts out of the hub plate with a hammer and punch. Remove the other 3/8-inch bolt in the same manner and remove the C-clamp and tighten the bolts. The hub should now teeter freely. Grease the outboard and inboard pitch pins on the hub and install the thrust blocks on the hub without the elastomeric thrust bearings. Make sure to match the block marked M to the master end of the hub and the block marked S to the slave end of the hub. Also, both blocks have a top side. To help in mounting the rotor blades, it is helpful to fabricate this fixture, which clamps around the tail boom at the third bulkhead and supports the end of the blade approximately 30 inches above the top of the tail boom, as shown. With the help of someone, mount the first blade to the rotor hub using the tail boom fixture to support the blade end. Adjust the hub to align the outboard pitch pin with the inner race of the liner block bearing. Slide the blade far enough to install the 9/16" retention bolt and the pitch horn through the straps and thrust block. If the blade does not slide on far enough, verify the teeter stop, which is the lower blade strap, is not pushing against the rubber sleeve. If it is against the rubber sleeve, Adjust the tail boom bracket to raise the blade slightly and install the 9/16 inch bolt. Note, you will be instructed later to shorten the strap. The 9/16 inch bolt should slide in fairly easy when the blade and hub are in proper alignment. Do not force this bolt in with excessive pressure. Have the person helping you lead or lag the blade slightly to aid with bolt installation. Tighten the nut to snug, and then push outward on the rotor blade straps to seat the thrust block against the thrust washer. Then tighten the bolt. Do not torque this bolt at this time. To mount the other blade, you will need the person who is helping you be in a position to maneuver the blade up and down, and along with lead or lag movements in relation to the rotor hub. The blade must be held in the pre-coned position. A good way to verify the correct angle is to look at the blade straps in relation to the thrust block. Tighten the nut to snug, and then push outward on the rotor blade straps to seat the thrust block against the thrust washer. Then tighten the bolt. Do not torque this bolt at this time. Do the static lead lag adjustment. Make sure the main shaft is level both lateral and fore and aft. Make sure the hub plate is level laterally. Each blade must be level in relation to the lead lag position and must float freely on the pitch pins. To make the proper lead lag adjustments, level each blade by loosening the set screws and the two 5/16 inch bolts that secure the liner block. Then adjust the blade by either leading or lagging it with the all-thread 1/4 inch bolts. Use a level on the blade strap. Switch back and forth from bolt to bolt to maintain a level static lead lag adjustment. Next, tighten the two aligner block 5/16 inch bolts. Then tighten the 4 set screws. Always monitor the level on the blade strap to maintain a level static lead lag adjustment. This can be a sensitive adjustment as you tighten the bolts and set screws against each other. Reference the construction print E20-2000 for the final torques of the 1/4 inch all thread bolts, the 5/16 inch aligner block bolts, and the set screws. Make sure the level bubble is in between the lines after you have torqued the bolts. With the blades teetering freely, set the end plugs and their wood screws on the ends of the blades. The tip weights and their screws and nuts must be in their position. Teeter the blades. The hub will return to a level position if the static balance of the blades are equal. Notice the slave blade on this ship is slightly heavier. Weight will have to be removed until the hub is level. Install the tip weights. Install the end plugs using 3M structural adhesive and the wood screws as per the construction print. Replace the two 3/8 inch teeter block bolts one at a time to prevent excess strain on the other teeter block from the weight of the two main rotors. Place a small amount of grease on the bolt threads and drive the bolt in. Torque bolts to 24 foot-pounds. Install two 5/16" bolts in the pitch horn clevis that have been ground to a point. Lift the pitch horn high enough to allow the point of the bolt to touch the main drive pin. Rotate the pitch horn and clevis by tapping lightly with a mallet to align the point of the bolt with the center of the drive pin. Connect the control rods between the pitch horn clevis and the rotating swash plate. Use two long 5/16" bolts of the same length in the rotating swash plate when installing the control rods. Place a straight edge and a level on the bolts extending from the swash plate. Level the swash plate. Adjust the control rods to level and cord line of each blade. The hub plate must also be level at the same time. Measure the distance between the main shaft and the control rods even with the bottom of the hub plate. The distance must be the same on both sides. Mark the retention strap with the two 3/16" holes that are to be drilled that secure the pitch horn to the top blade straps. Do not drill these holes while the blades are mounted to the rotor hub. You will be instructed to remove the blades shortly. Make sure the main shaft is 90 degrees to the ground, fore and aft. Then slide the rubber shaft protector on the main shaft upward. Teeter the blades so that they are 7 1/4 degrees to the shaft. Slide the rubber down until it rests on the strap and mark the edge of the bottom strap. Do the same teeter the opposite way and mark the edge of the other strap. Remove the blades and drill the 3/16" bolt holes and trim off the retention strap where marked. Install the pitch horn to the blades with the two 3/16" bolts. Check the fit of the 9/16" bolt. The main rotors will be reinstalled in Section 25 rigging. Engine first start preparation and procedures, along with the testing of the main rotor system, will be included in an expanded Section 26. Review all of the construction prints and follow the details of this section thoroughly. Although many details may repeat previous instructions given throughout the videos and manuals, Rotorway feels that this is absolutely necessary to stress the importance of the rigging procedures. The battery should be disconnected at this time. The purpose of the tail boom is to hold the trim fins and the tail rotor in the desired location. If the trim fins and tail rotor are not in the proper location and set at the correct angle, the helicopter will not respond correctly in flight. To have the best stability, the following angles and distances must be correct. The angle of the top of the tail boom should be 2.5 degrees more than the angle of the square drive tubes in the airframe. The horizontal trim fin cord line should be parallel with the top of the tail boom. The vertical trim fin cord line should align 15 inches to 16 inches to the pilot side from the center of the main shaft. To verify that the cord line of the horizontal trim fin is parallel with the top of the tail boom, measure the thickness on both the leading edge and trailing edge. Divide each measurement by 2 to find the distance from the top of the fin to the cord line at that point. For example, the leading edge measures 980 thousandths, divide that by 2, and you get 490 thousandths. The trailing edge measures 88 thousandths, and divided by 2 equals 44 thousandths. Subtract the smaller number from the larger number, and you get 446 thousandths. Sand or grind a small piece of the wood to that thickness to be used as a spacer. Place the spacer on the trailing edge. Rest the protractor level on the leading edge and the spacer. The protractor is now parallel with the cord line of the fin. Check that the cord line is parallel with the top of the tail boom. To verify that the vertical trim fin is at the correct angle, tape a piece of welding rod on the front and rear of the fin, extending about 1 inch. Sight across the welding rods from behind the ship. The rods should align between 15 and 16 inches to the pilot's side of the main shaft. The purpose of the cyclic control is to maintain the balance of the helicopter when it is in the air by tipping the swash plate. If the angles are not within the specified range of travel, the sensitivity of the control will be affected, possibly to the extent of being unable to control the helicopter. The angles that will give the pilot the best control throughout all maneuvers are as follows. The total travel from the left to the right stop should be 52 degrees. with equal number of degrees both directions from the center position. The total travel from the rear to front stop should be 52 degrees, with the rear stop set for pilot comfort. Note the cyclic control must tip the swash plate to the correct angle in reference to the main shaft for proper control of the helicopter. Set the protractor to read 26 degrees and place it on the side of the cyclic handle. Move the cyclic to the left until the bubble centers. Adjust the stop bolt so it makes contact with the cross shaft. Set the protractor to read 26 degrees in the other direction, leaving it in place on the side of the cyclic. Move the cyclic to the right until the bubble centers. Adjust the stop bolt so it makes contact with the cross shaft. Set the protractor level to read 26 degrees and place it on the rear of the cyclic stick. Move the cyclic to the rear until the bubble centers. Adjust the rear stop bolt against the stop bracket. Set the protractor level to read 26 degrees in the other direction and move the cyclic forward until the bubble centers. Adjust the forward stop bolt against the forward stop bracket. The purpose of the collective is to control the amount of pitch on the main rotor blades and the amount of throttle on the engine, which determines how much lift you have to work with. To obtain the best control of both items, the pitch of the blades and throttle, the collective control must be set up as follows. The collective control must have freedom of movement throughout its full range of travel, from the bottom of the pocket in the floor pan to where it contacts the airframe bracket. The throttle is checked by placing the collective in the full down position and twisting the throttle from stop to stop. The throttle transfer rod should rest on the fore-aft throttle shaft at each end of travel. The collective should travel a minimum of 16 inches from full down to full up position, measured from the center of the handle. The purpose of the anti-torque pedals is to control the pitch of the tail rotor blades. Changing the pitch on the tail rotor controls which way the helicopter will turn. To have enough control in all maneuvers and power settings, set the pedal travel as follows. The anti-torque pedal control should have freedom of travel from stop to stop with the push-pull cable traveling 2 7/8 inches. These are the stop bolts used to set the travel of the pedals. Push the left pedal to the stop. The tail rotor directional cable should move forward. Push the right pedal to the stop. The tail rotor directional control cable should move to the rear. The total travel of the cable should be 2 7/8 inches. The purpose of the tail rotor is to counter the effect of torque. If the tail rotor does not work properly, the helicopter will turn as soon as it becomes light on the skids, and there would be no way to stop it. Follow these steps when rigging the tail rotor. The key and the tail rotor shaft should extend the same amount out of the slider at each end of travel of the pedals. Note, to prevent lockup, the key must not extend more than 5/16 of an inch out of the slider. Reference construction print E17-2001 to fabricate from a 1/2 to 3/4 inch thick piece of wood this pitch checking template as shown. Place the arm in the full negative position. Note, the key should not extend more than 1/4 of an inch to 5/16 of an inch. Adjust each pitch length to 8 degrees reading as shown. Rotate 180 degrees to check the second blade. Adjust both blades as close as possible to 8 degrees negative pitch within 1/2 turn on the pitch link. After the negative adjustments are made, push the right pedal to its stop and check the pitch on both blades and verify that they are 24 degrees positive pitch. If the right pedal is at its stop and the pitch of the blade is more than 24 degrees, set the stop accordingly. If the right pedal is at its stop and the pitch of the blade is less than 24 degrees, recheck and verify the tail rotor cable range of travel is 2 7/8 inches. The rod end on the pitch horn should be centered over the 3/8" bolt holding the barrel to the shaft. Use washers if necessary to achieve this alignment. If more than 4 washers are required to position these rod ends, contact Rotorway technical support. Safety wire the bolts of the tail rotor assembly as shown. You will need to drill a small hole in the carriage slider assembly to safety wire these 2 bolts. The purpose of the tail rotor drive is to keep the tail rotor turning at the correct RPM. If the tail rotor drive is not installed or adjusted correctly, the pilot cannot correct for torque and maintain control of the helicopter. When rigging the tail rotor drive, do the following. Check to ensure that the idler pulley mounting scissors at bulkheads 2 and 3 can pivot freely. If you have not installed the belts, do so at this time. Fully loosen the nuts on the all-thread adjustment rods so that the belts are not under any tension while being installed. Never install a belt by rolling it into place over the edge of a pulley while under tension, as this can damage the belt internally. To adjust the belts, first loosen the rear 1/4 inch bolts on the tail rotor shaft bearing flanges. Then turn the 5/16 inch nuts on all the all-thread rods clockwise to tighten the belts. Initial tensioning. Check the tail rotor drive belt tension at the front of the number 1 bulkhead. Push the belt with the belt tension tool until it indicates 10 pounds. Use a ruler to check the distance that the belt moves. Adjust the tension until it deflects 1 3/8 inches at 10 pounds. Do not over-tighten the belts. When the belts are at the correct tension, retighten the 1/4 inch bolts on the bearing flanges. Check the rear drive belt tension by inserting the tool in a small hole towards the rear of the tail boom on the passenger side. Push up against the belt until the tool indicates 10 pounds. The tool must not make contact with the tail boom skin, or an inaccurate reading may result. Holding this position, make a reference mark on the tool at the edge of the hole. When checking belt tension in the future, push the tool against the belt until the reference mark aligns with the edge of the hole. The tool must indicate between the tight and loose limit marks. The belt replacement label can be installed once the initial tension has been attained. Apply the label to the upper tail rotor slider stringer on the pilot's side. Align the new belt mark on the label with the rear edge of the bearing mounting plate. If the bearing mounting plate reaches the replace mark during subsequent adjustments, this is an indication that the belt is stretched beyond a safe limit. Any belt that is stretched more than 1 inch may be damaged internally. It must be replaced immediately, regardless of the number of hours it has been used. Make sure the temperature strips are installed on the 2 tail rotor idler pulleys and the drive pulley on the tail rotor shaft. The heat-sensitive dots will darken if the indicated temperature is exceeded. Examine the temperature strips before and after each flight. If the 170-degree dot darkens, it is an indication that a belt may be slipping or some other problem may exist. The problem should be identified and corrected before continuing flight. If the 180-degree or higher dot darkens, the belts have been damaged from the heat and must be replaced. Upon installing new belts, check and adjust the tension every 15 minutes that the engine is running, either idle or operating RPM, until no further adjustment is required. New belts will stretch rapidly during this time, and it is very important to prevent them from becoming too loose. A belt that is too loose can be damaged internally by rolling over the edges of the pulleys. It can also be damaged by the heat created from excessive slipping. Any belt that is rolled may be damaged internally and must be replaced immediately to prevent failure. The belts and pulleys should be kept clean and free of any oil, dirt, or other contamination. Use acetone and a clean cloth, damp but not dripping with acetone. When belts have stopped stretching and been tensioned for the final time, drill a 3/16 hole through the bearing plate assembly and the slider rail on the pilot side only, and install a 3/16" bolt. This is a safety bolt hole in case of adjustment rod failure. The main rotor blades are wings which lift the helicopter and pull it in the direction that you are flying. When the 2 blades are made the same and are adjusted so that they lift the same amount, the helicopter is a smooth flying machine. Rig the rotor system as follows. The rotor hub plate must be shimmed correctly on the main shaft. Center of the outboard pitch pins and the center of the main shaft must be in a straight line to within 5/10,000ths or a total indicator reading of 1/1000th of an inch. The main rotor shaft should be 90 degrees to the ground in all directions. The center of the 9/16" retention bolt should be 1.985 to 1.990 from the leading edge of the rotor blades. The thrust block should be installed correctly on the rotor hub. Both rotor blade cord lines should be level, with the control rod disconnected. Both rotor blades should be the same weight. Both pitch horns should be mounted to the retention strap the same. Set the pitch on the rotor blades using the control rods, with the swash plate 90 degrees to the main shaft. With the collective full down, both blades are set at 2 degrees negative pitch. Check the pitch on the main rotor blades when the collective is in the full up position. The pitch should be 9.5 degrees to 10 degrees positive. When the collective is at its stop in the up position and the pitch measures more than 10 degrees, it will be necessary to modify the stop on the airframe. Bolt a piece of shim stock to the bracket to adjust the correct pitch. This is necessary as too much pitch would produce rotor RPM decay. The teeter travel must be between 14 and 15 degrees total movement. If your blades are not installed at this time, do the following. Clean and apply a thin layer of the recommended grease to the inboard and outboard pitch pins. Install the thrust blocks with the master block on the end of the hub with the serial number. Check the fit inside the hub. Using the procedures in Section 24, install both blades to the rotor hub. Remember, the blades must be held in a pre-coned position and not allowed to droop until both 9/16" bolts are installed and tightened. Level the rotor hub laterally. If necessary, shim under the skids to level the hub. When the rotor blades are hanging unsupported on the hub, the blades must feather freely to do a static lead-lag adjustment. Loosen the 5/16" aligner block bolts and the Allen screws. Use the all-thread 1/4" bolt to level both blades. The blade sweeps on the 9/16" retention bolt and pivots on the inboard and outboard pitch pins. When the blade is aligned with the pitch pins, it will level itself if it is free to pivot on the pitch pins. Check that the slave blade is level. Check that the master blade is level. The hub plate, master blade, and slave blade should be level when all the bolts are tight and the static lead-lag balance is done correctly. Check to see if both main rotor blades are the same weight. Replace the 3/8" bolts in the teeter block with 1/4" bolts one at a time to allow the hub to teeter freely. Place the level on the hub plate under the main drive pin so the weight of the level will not affect the balance of the blades. The blades should teeter freely and return to the balanced position. If they do not, remove weight from the tip weight of the heavier blade until the bubble centers. Be sure the wood end plugs and their screws are on the ends when checking the balance. When the balance is correct, install the tip plugs in the end of the blades, securing them with structure adhesive and wood screws. Remove the 1/4" bolts and reinstall the 3/8" bolts in the teeter blocks one at a time. Verify the position of the pitch horns. With a long 5/16 inch bolt ground to a point, install it in the pitch horn clevis. Raise the pitch horn and verify that the point aligns with the center of the drive pin. Reinstall the control rods and adjust them so that the swash plate, rotor hub, and both rotor blades are level. Slide the rubber collar down as far as possible and check the distance between the main shaft and the control rods. Both sides must be equal. With the rotor blades, rotor hub, and swash plate level, verify the pitch of the main rotor blades. Collective down both blades should have a 2-degree negative pitch. Collective full up, both blades should have a 9.5 to 10-degree positive pitch. Verify that the collective and the cyclic do not interfere with each other. Look closely at the pitch horn clevis and the rod end on the control rods. They must have adequate clearance in all control positions. It may be necessary to foul the clevis slightly so the rod end does not bind against the clevis opening. Also, make sure the thrust blocks and blade straps do not interfere with the hub plate in all cyclic and collective control positions. The main drive belts turn all the rotating parts in the helicopter. If the belts are dirty or loose, they will slip and the parts will not turn at the correct speed. When this happens, the helicopter will not fly. To verify the belts have been installed correctly, do the following. The belts and pulleys should be clean. Use acetone and a clean rag. The rag should be damp, but not dripping with acetone. To verify the pulleys are properly aligned, level the secondary pulley by shimming under the skids. Level the engine flywheel by moving the top or bottom of the engine. Remove the bolt that holds the rod end to the clutch arm casting and the top belt of the fan countershaft drive. Make a mark on the side of the engine pulley, 200 thousandths from the top of both sides of the aircraft. This is necessary because the top of the pulley has approximately 200 thousandths more material above the belt grooves than the secondary pulley. Remove the pivot bolt that holds the clutch arm casting on the passenger side. This is necessary so you can move the arm out of the way to use a straight edge on the pulleys. Place a straight edge on the top of the secondary pulley. The straight edge should be even with the mark on the engine pulley. Reinstall the clutch arm and place a straight edge on the secondary and verify the idler pulley is level with the secondary pulley. The pilot's side is the tension side of the pulley, so if you have to choose one side to be perfect, use the pilot's side. Be sure the belts are at the proper tension. Caution, do not over-tighten the belts. Achieve the correct tension and adjust as necessary to maintain the correct tension. Apply 7 pounds of pressure with a spring scale to one drive belt on the pilot side. It should move 1/2 inch. The idler pulley should not be touching the belts when making this test. Install the bolt that holds the rod end to the clutch arm casting. Note, it is important to maintain clearance between the clutch tube and the square drive tube. When the clutch is engaged, the piston in the spring tube should move 1 inch. Make sure the pivot arm bolt, the piston, and the springs in the spring tube have been greased. Verify and make sure the clutch arm casting does not touch the piston tube. The swash plate is a disc that, when tipped at an angle to the main shaft by the cyclic control, makes the main rotor blade tip to the same angle. The swash plate tips the main rotor blade in different attitudes to maintain balance of the helicopter in flight. When rigging the swash plate, do the following. All angles of the swash plate are set in reference to the main rotor shaft. Note, use shims under the skids until the main rotor shaft is 90 degrees to the ground, both fore and aft, and laterally. When the cyclic handle is against the forward stop, the swash plate must tip forward 5 to 5.5 degrees down in the front, in reference to the main rotor shaft. When the cyclic handle is against the rear stop, the swash plate must tip 5 to 5.5 degrees down in the rear, in reference to the main rotor shaft. When the cyclic handle is against the left stop, the swash plate must tip 5 to 5.5 degrees down on the left, in reference to the main rotor shaft. When the cyclic stick is against the right stop, the swash plate must tip 5 to 5.5 degrees down on the right in reference to the main rotor shaft. The cyclic cables are to be adjusted with a bias as shown. Using a spring scale, pull 4 pounds to align the rod end with the slot of the swash plate to give the correct bias on the control cables. When the correct bias is achieved on the control cable, install the rod end in the swash plate opening. Both the lateral and fore-aft cables must have the correct bias. When setting the swash plate angles, the main shaft must be 90 degrees to the ground. Put 2 5/16" bolts in the holes and place a straight edge on them. Set the protractor level 5 to 5.5 degrees and set it on the straight edge. Center the cyclic fore-aft and against the left stop. Adjust the rod end until the bubble centers. Set the protractor to 5 to 5.5 degrees in the other direction and place it on the straight edge. The cyclic control should be centered fore-aft and against the right side stop. The bubble should center. If it does not, the ratio of the cyclic and swash plate is off. Check the moment arm at the end of the cable. The moment arm is the distance between the pivot point and the attachment point. Remove the long bolts and rotate the swash plate to check the fore-aft angles. Install the long bolts and straight edge. The cyclic should be centered laterally and against the forward stop to set the angle. Set the protractor to 5 to 5.5 degrees and place it on the straight edge. Adjust the rod end until the bubble is centered. Set the protractor to 5 to 5.5 degrees in the other direction and place it on the straight edge. The cyclic should be centered laterally and against the rear stop. The bubble should center. If it does not, the ratio of the cyclic and swash plate is off. Check the moment arm at the end of the control cable.